Let's talk about power as it applies to circuits. Now remember, the power is the rate at which energy is transferred or transformed. And so back in Physics 1, we had a formula like this, delta E over delta T. But now we are talking about circuits and electronic devices and such. Okay, well, we have a formula that more specifically applies to those. I'm not going to go through and derive it. It's not necessary. We can just state it. P equals IV. This formula here, you take the current times the voltage, this will tell you the rate at which energy is transferred or transformed. And remember, power is measured in watts. That's a joule per second. And this formula here that I've just written, this applies to any circuit or electronic device. We can use this. This applies to anything, any situation, whether it involves circuits or cars or people or moose, it doesn't matter. P equals delta E over delta T, always true. This for any circuit or electronic device. Now we can take it one step further. We can say, well, let's talk specifically about resistors. Well, resistors obey Ohm's law. And so if we use Ohm's law, we know that V equals IR. And so what we get is that in that case, I squared R. So for resistors, we have a very specific formula. This is resistors only. So this is for circuits and any device. And this is always true up here. But this last one, this is resistors only. And to be specific, I squared R, that is the power loss. That is the rate at which electrical energy is being transformed into thermal energy. And so that means it's gone, it's lost. So when you talk about the power of a power line, or let me rephrase that, when you're talking about the thermal losses of a power line, you're talking about this term here, I squared R. You take the current, you square it, you multiply it by the resistance of the power line. That's the power loss. That's the rate at which energy is being lost by virtue of passing through the power line or any wire. This is always going to be the case.